This video is just meant to be an overview of different stoichiometry calculations. On each page, I will be showing how to set up the calculations, but I will not be punching the numbers into a calculator and finishing any of the problems. If you are working along to learn how to map and do stoichiometry calculations, you should pause the video and finish off calculations, and you can check back in with me if you need any kind of extra help or aren't sure how to finish a calculation. There are four types, basically, of stoichiometry calculations that serve as the foundation of all stoichiometry calculations. So we're going to start with mole-mole. When we have a mole-to-mole calculation, you'll see that in the problem you have been asked about moles and given moles. So in this case, we can see that it says how many moles of hydrogen reacted with excess iron 2 oxide to form 4.3 moles of iron. So I'm going to put mole underneath hydrogen in a box. That's indicating that I'm trying to get to the moles of hydrogen. And I'm going to put excess underneath the Fe2O3 because it's telling me that I have excess. And then I'm going to put a 4.3 mole underneath the Fe. And that tells me that I'm trying to get from moles of Fe and I'm trying to land at moles of H2. Before I do anything, calculations-wise, I need to look and see and make sure the equation is balanced. And I can see that I have 3 oxygens over on the left, so I want to get 3 oxygens over on the right. That gives me 6 hydrogens, so I need 3 over here to balance for the hydrogens, and then I need 2. If you have a complicated equation to balance, you should make sure that you do work to help you to keep track of the balancing. So I can see that I have 4.3 moles of Fe to begin with, times fraction. I'm getting rid of moles of Fe, so that's going to go on the bottom. I'm trying to get to moles of H2, so that's going on the top. And then I'm going to use this mole ratio, this 3 to 2 mole ratio. 3 moles of hydrogen for every 2 moles of Fe. I can now see that the moles of Fe cancels. That's going to leave me with moles of H2. Moles H2. I'm going to put that in a box, and I'm going to punch that into my calculator, and I'm going to pay attention to sig figs. I see that I have 2 sig figs, 2 significant figures. So I know my answer is going to have 2 sig figs. The rest is just punching it into the calculator. The second problem on this page I can see is saying to me how many moles of oxygen gas. So I'm going to put moles underneath the oxygen gas are formed when 0.35 moles of hydrogen peroxide decomposes. That means I'm starting over here at hydrogen peroxide and I'm trying to get to oxygen. Again, before I go any further, I should look to see if my equation's balanced, and I can see that I've got 2 and 2, I've got 2, and I've got 3. I'm going to put a 2 here because that's going to give me an even number of oxygens. 2 and 2 is 4, but now that's also going to give me 2 hydrogens. So now my equation's balanced. I've got 0.35 moles of H2O2 to begin with, times fraction. I'm getting rid of moles of H2O2. I'm trying to get to moles of O2. Again, I look at the balanced equation and I can see my ratio is 2 to 1. I have 2 moles of H2O2 for every 1 mole of oxygen. Moles of hydrogen peroxide cancels, leaves me with moles of O2. Put a nice little box for my answer. Again, I've got 2 sig figs. I'm just going to indicate that for myself. Then it's about going into my calculator and punching it in. So that covers mole-to-mole calculations. Mole calculation serves as the foundation for all other calculations. So the truth, though, is when we're in the lab, we don't measure moles. We tend to measure mass or volume when we're talking about different substances. But a lot of times we're going to see in our calculations and in our work, it's going to ask us about mass. So here we see what mass of silver nitrate reacted. So I'm trying to get to grams of AgNO3. There's 65.0 grams of copper 2 nitrate was produced. So I got 65 grams here of copper 2 nitrate is where I'm starting. So in this case, you're given grams to grams. Well, when I look at the balanced chemical equation, so it's balanced, I need a 2 there and a 2 there. This ratio that we were using represents a particle ratio or a mole ratio. It does not represent a mass ratio. So to get from grams of one substance to grams of another, you first have to calculate the number of moles. Once you have the number of moles, you can calculate the number of moles of the other substance, and that's the step we just learned on the page before. Then I can go from moles of silver nitrate up to moles of grams. So we can see now that we have this map, and we can see that we have 3 different steps that we're going to need to do. First, we're trying to go from grams of copper nitrate down to moles of copper 2 nitrate. In order to go from grams to moles, you might remember that we need molar mass. So a good strategy is to make your little list off to the side. I've got 2 nitrogens, I've got 6 oxygens, so I would go look up the molar masses of these different substances, and I would then add those up, and that then is going to give me the conversion factor. So 6 times 16, 2 times 14.01, and 63.55, all from the periodic table. You would multiply that out and add that up, and that would then give you the molar mass for copper 2 nitrate. You'd want to do the same thing over here for the silver nitrate. You've got the Ag, you've got the N, you've got 3 O's. You would go look up those molar masses on the periodic table and find 107.87 and 14.01 and 3 times 16, and add that up, and that'll give you the molar mass for silver nitrate. And now you have all the information that you need for your different calculations. You have the molar mass as a conversion factor. You have the mole ratio as a conversion factor, and you have your other molar mass as a conversion factor. So we're starting with our 65 grams of copper 2 nitrate times fraction, getting rid of the grams of copper 2 nitrate and going to the moles of copper 2 nitrate, and that's 1 mole of copper 2 nitrate for whatever that molar mass comes out to be, times fraction. Then I'm getting rid of the moles of copper 2 nitrate, and I'm going to moles of silver nitrate, and this is where I'm using the 2 mole to 1 mole ratio that I got up here. Critical that you see that this 2 to 1 ratio is the 2 to 1 ratio that we're using from the balanced equation into the stoichiometry. And then looking at my units, I can see that the grams of copper 2 nitrate cancels with the grams, the moles cancels with the moles, and now I'm trying to get rid of the moles of silver nitrate, and I'm going to the grams of silver nitrate, and that's where that second molar mass is going to come into play. For every 1 mole of silver nitrate, I'm going to add up these masses to get to the molar mass, and that's going to cancel out the moles, and it's going to leave me with grams of AgNO3, and I can put that in a nice box, and I can see that I have 3 sig figs. So at this point, I've really earned the bulk of the points. It's just about going and punching numbers into my calculator. So I'm going to want to calculate the molar masses plug those numbers in and then put it into my calculator and see where that lands me.